So hi, Assalamualaikum. My name is Nurani Soida, and today I'll be presenting about our group project for computer architecture. So the list of content that we have is objective, purpose, calculator functions, design, user manual, challenges, and lesson learned. The objective that we have are to understand the number system used in computer architecture, to familiarize with assembly language program, to enhance the presentation skills and teamwork among group members.
The purpose of the programmer calculator is to help user convert number between different systems, decimal, binary, and hexadecimal, and perform basic Boolean operation AND, OR, XOR, and NOT on binary numbers. This aids in understanding how numbers and logical operation work at a low level, which is essential for tasks like debugging, system programming, and working with the hardware. By using this calculator, programmers can see how different number systems interact and how bitwise operation affect data, enhancing their skill in low-level programming and problem solving. For the overview, the programmer calculator offers essential features for Boolean operation and number system conversion. It enables users to convert decimal numbers to 16-bit binary, 16-bit binary to hexadecimal, and hexadecimal to decimal. It demonstrates logical comparison, bit manipulation, and bit inversion, improving programmers' comprehension of low-level data representation and operations. The programmer calculator allows users to convert decimal numbers to 16-bit binary, 16-bit binary to hexadecimal, and hexadecimal to decimal. It also executes Boolean operation on 16-bit binary value such as AND, OR, XOR, and NOT. This enhances programmers' understanding of low-level data representation and operation.
So next is calculator design, and the first design that we have is high-level design, which includes listing efficient modules for passing user input, performing conversion, and Boolean operation and generating input. So by dividing the calculator functionality into distinct modules, the design promotes maintainability and reusability. In addition, each module focuses on a specific task, allowing for easier debugging and testing. The efficient design also enables user to perform number conversion and Boolean operation accurately while providing the user a clear and concise output. It's very important to note that the actual implementation may vary depending on the specific programming language. So next is for assembly language. We choose assembly language because of its direct hardware control and speed, providing an insightful learning experience about low-level programming. So assembly language program may be complex of time-consuming compared to higher level language. By utilizing assembly language, we can build an efficient and lightweight program. Depends on our understanding of low-level program language. Besides, we have Boolean operation implementation such as AND, OR, XOR, and NOT. So by utilizing this bitwise, we can perform Boolean operation effectively and accurately for a programmer when working with binary data and logical condition. Moreover, conversion, presentation, by dedicating specific assembly routines for each conversion between decimal, binary, and hexadecimal, we can optimize the efficiency of the calculation. Assembly language also allows us to have a great control over the operations and memory, resulting in faster and more streamlined conversion between number system. This conversion provide programmer with a convenient tool to convert number between different systems effortlessly, such as convert decimal number to binary for bitwise operation. Moreover, our calculator enables efficient and accurate coefficient to faster interpret for easier integration. So next for design section. There are three parts of calculator section as shown in the slide, which are data section, text section, and BSS section. As you can see, the design of calculator in data section that we have is menu such as welcome to programming calculator and a lot of section options for number conversion and boolean operation. Next, as for text section, it contains the actual code instruction of the program, including input validation, calculation execution, and result display. It's like a way of assembly language and linking, where the examiner converts the assembly language instruction in the text section into a machine code, and with the link combines the text section to the other section and numbers to create the final executable file. Next, as for BSS section, this section is used to store uninitialized data. As for BSS section, it can be simplified as programming task and optimize the memory uses.
So for the user manual, firstly, when the user loads the calculator, a menu will be shown as given by the picture. The menu will show the user all the possible options that can be chosen by the user. To start using the calculator, a user just need to choose the option they want to and enter the input into the calculator. For an example, if the user choose number 1, which is the decimal number converted into binary number. As shown in the picture, when the user choose number 1, the calculator will prompt the user to enter the decimal number, which then will be converted into its binary equivalent as shown in the picture. Next, if the user chose option number 2, which is to convert decimal number to hexadecimal number, the calculator will then ask the user to enter the decimal number, which then the calculator will convert the number into its equivalent decimal number. Another example, when a user chose option number 3, the calculator will prompt the user to enter any binary number, which then will be converted into its decimal equivalent. Another example can be shown in the picture as the user chose option number 4. When the user chose option number 4, the calculator will ask the user to enter any binary number, which then the calculator will convert the number given into its hexadecimal equivalent. The rest can be proved as true as shown in the picture. This user chose the number 5 option, which is to convert a hexadecimal number into a decimal number. Moving on, when the user choose option number 6, the calculator will prompt the user to enter any hexadecimal number, which then will be converted into a binary number given by the user.
We have Boolean operation. As you can see, we have 4 different operations, which is AND, OR, XOR, and NOT. For example here, if the user choose option number 7, which is AND, calculator will prompt the user to enter two 16-bit binary number, as well as OR and XOR. We have more than that. We have NOT operation, which is option 10. The calculator will prompt the user to enter a binary number. Other than that, if the user chose option 0, the calculator will stop prompting and display thank you. Lastly, if the user enter an invalid option, The calculator will show an error message and prompt the user to choose again. On to the next presenter. Thank you.
Let's look at the challenges. For the first and foremost, developing functionality of the calculator, we have encountered several troubles to perform mathematical operations, specifically Boolean operators and number conversion that to be executed in this program. Next, the implementing assembly language. Since we are just introduced to the assembly language not long ago, which is just recently, we barely grasp anything in such a short amount of time. So it took us quite a while to finally create this program as well as understanding this language. Next is designing user interface. Since we aim to create an accessible and user-friendly design, it is quite tricky to get this program to display our desired result on screen. And next is debugging. Since our program has two operations, it is harder for us to debug our program. This makes our program to be more prone to mistakes and minor errors. To conclude, based on this project, we are able to gain a deeper understanding in number system and its conversion as well as the Boolean operation. For example, number conversions such as binary to hexadecimal and vice versa, and such the XOR, NOT, and OR operation. Next is that we are able to design an interface that is user-friendly. It is shown on screen that from the start of the program, it will display a menu allowing the user to input their choices to get their own result. Finally, we are able to develop skill in implementing mathematical operations using assembly language. It is quite hard for us to implement it in the start of this project, but we eventually are able to do so thanks to our teamwork and group members. That's it. Thank you.